So, good morning, all of you, and welcome to the lecture of MSCET course on physics. I am Dr. Sajid Mullah, and in this lecture, I would like to explain the chapter number 8 of your subject. The name of the chapter is electrostatic. Today, I would like to explain what is a electrostatic, then what is the electric field intensity, and then I would like to solve the various example which were asked in the MSCT exam and other JEE exam or IEEE exam. Isn't it? So let we start. So electrostatic. What is mean by static? The static means a stationary. And electro, the field or electric field that is developed by stationary charge is called as a electrostatic field. Isn't it? So let we try to understand what is mean by field. So what is a field? The field is nothing but some information that is created around the object. And what is a vector field? The vector field is a information that contains both direction and magnitude at every point in the space. For example, the gravitational field, the electric field and magnetic field. So all of you know about the gravitational field. The gravitational field is developed around the Earth's surface, you know. And what is the direction of the gravitational field? The gravitational field is directed towards the Earth's surface. So in this figure given here, the Earth is shown over here, and the gravitational field is directed towards the Earth's surface. As far as Earth's surface is concerned, the gravitational field is exactly normal to the Earth's surface, isn't it? And if any object is placed in the media of the gravitational field, then what happens? The mechanical force is exerted on that object. And that mechanical force is directed towards the Earth's surface. You take an example of a stone. Let's consider there is no force required because it naturally moves in the direction of gravitational field, isn't it? So that is the property of the field. The field is nothing but a region where the force is exerted on the object. These line of fields are represented by the line, and it's an open line, not a closed path, isn't it? So electric field is a vector, but this vector is a irrotational vector. It is represented by a straight line. Did you understand? Now, on basis of this property, the question may be asked. So let me discuss one question. So look at this question. Question number 3. Which of the following figure cannot possibly represent electrostatic field? Isn't it? So 4 options are given. Now you know the electric field is originating at one point and terminate at other point. So option number 2 is a valid answer for electric field because it originate at one point and terminate at other point. And it has only one direction because it is irrotational field, isn't it? But in the first option, the arrows are given. This is a line which indicate both two directions, isn't it? So electric field is represented with help of two direction, but electric field is always omnidirection, or we can say it has only one direction, isn't it? So the first option cannot valid for representation of electrostatic field. Look at the third option. Now here the electric field is crossing to each other, and as I mentioned, the electric field is always represented by line, and this line of electric field cannot be crossed to each other. Are you getting? So this third option is also not valid because these lines are crossing to each other and electric field cannot cross to each other. Now let we discuss the fourth option. In the fourth option also, the line of electric field is represented by loop here. But as I mentioned, the line of electric field is always represented by line, and its direction is a unidirectional, not bidirectional. Here the two arrows are given. It indicates this field is represented by two directions, but electric field always represented by only one direction. So option number 1, option number 3 and 4 are not valid for representation of electric field. Are you getting? However, the option number 2 is valid for representation of electric field. So which is the correct answer? Correct answer is 1, first, third and fourth only cannot possibly represent electrostatic field. Now let me discuss one more example regarding the electric field. Here the two charges are given, Q1 and Q2. You read the question. The figure gives electric line of force due to two charges Q1 and Q2. And what are the sign of the charges? So you have to identify what is the sign given to charge Q1 and Q2. As you know the property of electric field, the electric field is originating from positive charge and terminating at negative charge. So look at this figure. This line of fields are terminating at this Q1. So definitely Q1 must be negative, isn't it? So this charge must be negative. Why it is negative? Because the line of fields are terminating. And what about this Q2? Here also at Q2, the line of electric fields are terminating. So Q2 has also negative charge. So according to the property of the line of field, the sign is given to both Q1 and Q2. So options are both are positive, both are negative. Q1 is positive, but Q2 is negative. Q1 is negative, but Q2 is positive. But correct answer must be both are negative, because the line of electric fields are terminating at negative charges. Are you getting? So this kind of question may be asked. Now here, look at this question. This question is asked in the IIT exam. You can read the question first. The metallic shell is given. So this shell or sphere, we can say, the metallic sphere is given, and the sphere is a hollow sphere, and inside the metallic sphere there is a charge. The charge Q is placed, isn't it? And you have to identify which figure is correctly represent the electric field or line of electric field. So before solving this example, you should know the properties of electric field. One of the important property of electric field is that the electric field cannot be passing through the conducting medium. As soon as this electric field entered into the conducting medium, that electric field becomes zero. You cannot observe electric field inside the conducting medium, isn't it? In fact, electromagnetic wave also uh, cannot propagate in the conducting medium. You can experience the example of the mobile. You cannot receive the mobile signal inside the room if room is closed, because wall of the room are act as a conducting medium, and the electromagnetic wave cannot be passing through the conducting medium, isn't it? So that is an important property. Now look at the representation of line of field. So this is a shell and charge is placed inside the body. So line of field is now here passing through the conducting body. So this is not a valid representation of line of field, because the electric field cannot be passed through the metallic body. So this is not valid answer. Now look at the figure 2, figure number B, isn't it? Here also the line of electric fields are passing through the shell. But you know the line of field cannot pass through the metallic shell. So this option is also incorrect option, isn't it? Look at option number D. Option D. Here the line of field. This line of field is passing through the metallic body. But that is not valid answer. But option C is a valid. Why it is valid? Here in the metallic shell or metallic wall, the line of fields are not shown over here, isn't it? It indicates that the line of field are not passing through the metallic shell. So option C is the correct answer, isn't it? So in this way you can find the answer of the question related to electric field or electrostatic field. Now we'll move to the Gauss law and electric field intensity. So let me solve one example related to Gauss law. So this example is given here. It is related to Gauss law. The electric field due to uniformly charged sphere of radius r as a function of distance from center is represented by which graph? It is based on Gauss law. You studied Gauss law in 11th. So what is Gauss law? The Gauss law states that the total charge placed inside the closed surface, let's consider one closed surface of radius r, and if charge is placed inside the closed surface, let's consider Q be the charge placed inside the closed surface, then line of flux will cross over the closed surface. And according to Gauss law, the line of flux crossing the closed surface phi is equal to surface integration of E bar dot ds bar. Here what is E bar? E bar is the electric field intensity and ds bar be the surface area. Integration of ds bar is the area of sphere, isn't it? In the simple way, we can find the flux crossing the surface of the sphere is equal to E into S, where E is the electric field. What is E? E is the electric field. And S be the surface area of the sphere. Isn't it? For the sphere, the surface area is 4 pi r square. 4 into pi into r square. Into E gives the flux crossing the area. So in the given example, now we have to solve this example. What is the electric field? Due to uniformly charged sphere, one sphere is given. So I would like to draw the sphere. And the charges are given on the sphere. Let's consider Q be the charge induced on the sphere. And the radius of the sphere is capital R. Isn't it? And we have to find the electric field at point P. So let's consider the distance between point P and the charge body is small r. The small r is the distance between charge body and P, and capital R be the radius of the sphere. So at P, the electric field is the charge divided by 4 pi epsilon 0 multiplied by r square. So what is r? R is the distance between point P and the center of the sphere, isn't it? And Q be the total charge. Now we can find the surface charge density of the sphere. So how to calculate surface charge density? The surface charge density is denoted by sigma. The surface charge density is defined as charge per unit area, where S be the area of the sphere, isn't it? The total charge on the sphere is Q. And what is the spherical area or area of the sphere of radius r? The area of sphere of radius r is 4 pi into r square, isn't it? So what is total charge in terms of the surface charge density? The total charge in terms of surface charge density is sigma into 4 pi r square, isn't it? Now we can represent electric field in terms of surface charge density. The electric field in terms of surface charge density is E is equal to sigma 4 pi r square. The Q is replaced by sigma 4 pi r square divided by 4 pi epsilon 0 r square. Now you may cancel the 4 pi, and the electric field in terms of small r and capital R and surface charge density is sigma into capital R square divided by small r square. So we can see over here the electric field is inversely proportional to 1 upon r square from distance capital R, isn't it? So this equation is satisfied for capital R or you may write in terms of small r. The small r is greater than capital R, isn't it? So if your point is located outside of the sphere, then what is the electric field? Electric field is sigma capital R square divided by epsilon 0 R square. Or simply we can write electric field is inversely proportional to R square for the region R greater than capital R. But if R is less than capital R, then what will be the electric field? Now look at the region inside the sphere. There is no charge present over here. So what will electric field? The electric field is zero inside the sphere. And outside the sphere, the electric field is inversely proportional to R square. So what will be the correct option? Look at the graphs. The first graph is given here. Here, inside the sphere, this region is a region inside the sphere. R is less than, एक minute, small r is less than capital R. And for the region outside of the sphere is small r greater than capital R. You know that inside the sphere there is no electric field. So option A is wrong. Is incorrect. Is option B correct? No, because here inside the sphere, in this graph, we can see electric field is linearly increasing. But you know that electric field inside the sphere is zero. So which option is correct? Option C is correct. Because inside the sphere, electric field is exactly zero. And outside of the sphere, the electric field is inversely proportional to square of distance r. So option C is the correct option, isn't it? In this way, you may calculate electric field and you can draw the graph of the electric field versus R. Now, this example is also based on Gauss law. What is the Gauss law? Statement of the Gauss law? The total charge present inside the closed body is exactly equal to the line of flux crossing the closed body. So here in this example, one Gaussian surface is given. You know the Gaussian surfaces may be a sphere, it may be a cylinder. Here the sphere is given. This sphere is a hollow sphere. And inside the sphere, Q1 and minus Q1 are located, isn't it? And outside of the sphere, charge Q2 is located. And the question is, the electric field on the surface will be. So what will be the line of electric field crossing the surface? So that is your question, isn't it? And according to Gauss law, you know, the flux crossing the closed surface is equal to surface integration of E bar dot ds bar. To have the flux outside of the closed surface, electric field must be non-zero. But look at the example here. The plus Q1 and minus Q1 charges are located inside the closed body. So what will be the total charge? The total charge inside the closed body is Q1 minus Q1. So total charge inside the body is exactly equal to 0, isn't it? So as total charge inside the body is 0, the flux will 0. There is no flux crossing the closed surface. Why? Because total charge is 0. So as flux is equal to 0, the line of electric field will also 0. So this equation, after solving the equation, we'll get the electric field E bar is equal to 0, vector field, or scalar or magnitude of electric field is equal to 0. Isn't it? So correct option is 0. So it's very easy to solve the example, such example, you can apply basic uh, concept of the Gauss law, isn't it? Now, this example is based on the charge density and the Gauss law. The example is given: a charge of 8 microcoulomb given on metallic sphere of radius 5 centimeter placed in the medium of dielectric constant. The question is the surface charge density of the sphere. What is the surface charge density? The surface charge density is defined as, you know the definition of the surface charge density. The surface charge density is defined as total charge present on the body divided by area of that body. Here in this example, one sphere is given and the radius of the sphere is 8 centimeter. Let consider capital R be the radius of the sphere, and this radius is given, it is 8 centimeter, isn't it? And total charge present on the sphere is how much? Q is equal to, Q is given 8 microcoulomb. 8 microcoulomb is nothing but 8 into 10 to the power minus 6 coulomb, isn't it? So which data we required? The charge is known, the area is required. And how to find the area of the sphere? The area of sphere is, 4 pi into r square, isn't it? So surface charge density is sigma is equal to Q divided by 4 pi r square. So charge is given. What is the value of charge? 8 microcoulomb. 8 into 10 to the power minus 6 divided by 4 into pi into r square. R is 5 centimeter, not 8 centimeter. I have written mistakenly 5 centimeter, but exact radius is 5 centimeter. So it will be 5 into 10 to the power minus 2 square, isn't it? And you can solve this numerical. This will be 8 divided by 4 pi into 25 into 10 to the power minus 6 divided by 10 to the power minus 4. The surface charge density is 8 divided by 100 pi, 25 into 4 is 100, isn't it? Into pi into 10 to the power minus 2. Now you have to find the value 8 divided by 100 pi and multiply with 10 to the power minus 2, isn't it? So you can find the correct answer here, isn't it? So 8 divided by 100 pi, it is approximately equal to 0.254 into 10 to the power minus 2. So it will be 25.4 into 10 to the power minus 4 coulomb per meter square. So what is the correct answer? The 25.48 into 10 to the power minus 4 coulomb per meter square. So in this way you calculate the surface charge density, isn't it? So for confusion here, dielectric constant is given. The dielectric constant is pi. But you know that the surface charge density is independent of dielectric constant, isn't it? So even the dielectric constant is given, so don't confuse. If you know the definition of the charge density, you can find the charge density with help of the equation given. So in this way you calculate the surface charge density. Now let we try to solve the one more example. This example is asked in the MHTCET. So the example is given, what is the total electric flux through the entire area of the closed surface is given. And you know the definition of Gauss law. The Gauss law states that the line of flux crossing the closed surface is equal to surface integration of E bar dot ds bar, isn't it? The dot product is very important. As far as the line of flux is concerned, these are the electric flux, not magnetic flux. The electric flux is represented with the help of a straight line. And if any parameter that is represented by a straight line, then you require a dot product, not a cross product. When the cross product is applicable, if the vector is represented by circular loop, for example, magnetic field, the magnetic field is represented by a circular path. So in that case, you have to apply cross product. But we are dealing with the electrostatic field, and the electrostatic field is represented by a straight line. The path is open. For open path, you have to apply dot product. So which option is correct? According to Gauss law, this equation is correct. Option B is correct. Option A is incorrect. Why? Because here the cross product is applied. And cross product is not applicable for an open path or straight line. The cross product is applicable for a closed loop, isn't it? So this second option is correct option. So let we try to solve one more example. Now here the electric flux through the hemisphere, we have to calculate how much electric flux crossing the hemisphere, and the radius of the hemisphere is given capital R, and line of electric fields are parallel to the axis. So how to solve this example? It's very easy to solve, but you should understand what exactly given in the problem. So first I would like to draw hemisphere. Hemisphere is nothing but half sphere or semi-sphere. So this will be a hemisphere, isn't it? जशी टोपली असते ना तशी टोपली म्हणजे हेमिस्फिअरच असतो आणि त्याचा रेडियस किती आहे the radius of the hemisphere is capital R. And one more information is given. The line of electric field is parallel to the axis of the circular plane. आता इथे बघा हा सर्क्युलर प्लेन दिलेला आहे हा म्हणजे हॉरिझॉन्टल प्लेन आहे ते त्याला पॅरलल इलेक्ट्रिक फील्ड आहे ते असे हे इलेक्ट्रिक फील्ड आहे isn't it? आता इथे बघा या एक्झाम्पल मध्ये तुम्ही जर हे दोन सेक्शन जर डिवाइड केला इथे म्हणजे क्वार्टर स्फिअर जर केला तर तुम्हाला असं लक्षात येईल की लाईन ऑफ इलेक्ट्रिक फील्ड फक्त ह्या रिजन मधूनच पास होतात isn't it? बघा इथे the line of electric field passing through this only surface area या एरिया मधून फक्त पास होतं आणि तेच काढायचं आपल्याला अकॉर्डिंग टू डेफिनेशन. तर डेफिनेशन तुम्हाला माहित आहे काय आहे ते फाय इज इक्वल टू ई इंटू एस. इथं तुम्ही स्केलर क्वांटिटी घेतला तरी चालेल ई इंटू एस. आता ह्या रिजनचा सरफेस एरिया आपल्याला फाइंड आउट करायचा. तुम्हाला माहित आहे सरफेस एरिया ऑफ द स्फिअर किती असतो 4 पाय आर स्क्वेअर असणार आहे isn't it? And what is the surface area of the hemisphere divided by 2 करायचं म्हणजे किती येणार it will be 2 पाय आर स्क्वेअर येणार. तर आपल्याला काय पाहिजे we want the surface area of the quarter sphere म्हणजे SQ पाहिजे आपल्याला. SQ काढण्यासाठी काय करावं लागेल SH divided by 2 करावं लागेल and this is equal to pi r square. isn't it? SQ आहे. म्हणजे तुमचे फ्लक्स कुठल्या एरियामधून पास होतात? पाय आर स्क्वेअर या एरियामधून पास होतात. म्हणजे काय असणार बघा आन्सर? बघा, पाय आर स्क्वेअर इज द एरिया ऑफ 1/4 or quarter area of the quarter sphere, pi r square, multiply by electric field. Use the line of flux crossing that area. Option 1 here हा incorrect असणार, कारण 2 pi r cannot be a area of the surface. हा पण इनकरेक्ट आहे, कारण इथं r cube आहे. हा पण इनकरेक्ट आहे. The correct option is pi r square into E, isn't it? So this example is asking MHTCET. हा एक्झाम्पल हा कॅपॅसिटर वर आहे. आता बिफोर सॉल्विंग दिस एक्झाम्पल, आय वुड लाईक टू एक्सप्लेन व्हॉट इज अ कॅपॅसिटर अँड हाऊ टू कॅल्क्युलेट एनर्जी स्टोअर, isn't it? So capacitor is a component that can be used to store electrical energy. समजा तुम्हाला इलेक्ट्रिकल एनर्जी स्टोअर करायची असेल तर तुम्ही कॅपॅसिटर हा कॉम्पोनंट वापरायचा. तुम्हाला माहिती आहे, पाण्याच्या टाकीमध्ये आपण काय करतो? स्टोअर करतो, पाणी स्टोअर करतो. तो वॉटर टँक इज अ एनर्जी स्टोअरिंग डिव्हाइस आहे, isn't it? But pipe cannot be energy storing element or device. पाईप मधनं काय होतं? पाणी फ्लो होतो, त्यात पाणी साठवता येतं का? नाही. तसं there are two components in the electrical circuit. One is a resistor, or we can say conductor. So resistor cannot store energy, electrical energy or magnetic energy. In fact, it dissipates the energy. But capacitor will store a energy. And which kind of energy it will store? Electrical energy it store, isn't it? So capacitor is made by a two conducting plate separated by dielectric medium. The medium may be a air medium, it may be glass medium, or it may be mica. कुठलाही dielectric medium इथे घेऊ शकतो, isn't it? And let's consider C be the capacitance of capacitor, and the charge placed on the plate, let's consider Q. And be remember, one of the plate is a positive and second plate is with negative charge, isn't it? And you know the line of electric field is originating from positive charge and terminate at negative. So what is the direction of electric field? It will direct it from positive plate to negative plate, isn't it? And how to calculate capacitance of the capacitor? The capacitance of capacitor is equal to some dielectric constant multiply by area of the plate. The plate is nothing but a plain plate, and that has the area of A divided by distance D, where D is the separation between two plates. D is a distance between two plates or separation between two plates. So in this way you can find the capacitance. And total charge present on the capacitance is equal to C into V, where V be the voltage across capacitor. And you know the capacitor is an energy storing element. The energy stored in the capacitor can be defined as half into CV square, isn't it? Half into CV square. So that is a equation for energy store. Now you know C. What is C? C is epsilon 0 A divided by D, isn't it? And voltage is given here V square. You may write V into V. Instead of V square, I would like to write V into V. Where V divided by D, आता आणखी एक डेफिनेशन तुम्हाला लक्षात ठेवावं लागेल. कुठली डेफिनेशन, तर व्ही अपॉन डी म्हणजे काय, व्ही अपॉन डी म्हणजे तुमचा इलेक्ट्रिक फील्ड असतो, isn't it? V upon D is electric field. और डेफिनेशन ऑफ इलेक्ट्रिक फील्ड तुम्हाला माहित आहे काय असणार आहे, द रेट ऑफ चेंज ऑफ व्होल्टेज विथ रिस्पेक्ट टू डिस्टन्स. तर त्यामुळे बघा हे ऑप्शन तुमचा करेक्ट ऑप्शन आहे. आता तुम्ही ई म्हणजे काय घेतलेलं आहे ते, ई इज नथिंग बट व्ही डिवायडेड बाय डी, द रेट ऑफ चेंज ऑफ व्होल्टेज विथ रिस्पेक्ट टू डिस्टन्स इज द इलेक्ट्रिक फील्ड. And according to definition, the energy stored is half into C into V square. And what is C? C is epsilon 0 A divided by D. So option B is a correct option, isn't it? Half epsilon 0 K E square. आता D मध्ये काय दिलेलं आहे बघा, बोथ A and B करेक्ट आहे, म्हणजे ह्याला पण ट्राय करावं लागेल तुम्हाला, हा पण करेक्ट ऑप्शन आहे का बघायचं. आता हे कसं कॅल्क्युलेट करायचं बघा. आता ऑप्शन बी तर करेक्ट आहे, ऑप्शन बी इज नोन हाफ epsilon 0 is a media constant into K. K is a relative relative permittivity आहे. एअर असेल तर K ची व्हॅल्यू 1 असते आणि ग्लास असेल तर एअरची K ची व्हॅल्यू ग्रेटर दॅन 1 असणार आहे, मल्टिप्लाय बाय ई असणार आहे, ई स्क्वेअर. आता ई तुम्हाला माहिती आहे अकॉर्डिंग टू गॉस लॉ, ई इज इक्वल टू सिग्मा डिवायडेड बाय epsilon 0 इंटू आर स्क्वेअर आणि इथे कॅपिटल आर स्क्वेअर असणार. हे आपण लास्ट टाइम इथे सॉल्व्ह केलेलं आहे लास्ट एक्झाम्पल मध्ये. इथे आहे ना स्मॉल आर घेतलं तरी चालेल फॉर सेक ऑफ सिम्प्लिसिटी. हा कॅपिटल आर आणि स्मॉल आर तुम्ही सेम ठेवा आणि ते इथे रिप्लेस करायचं. इथे हाफ epsilon 0 K आणि ई स्क्वेअर म्हणजे काय असणार, सिग्मा स्क्वेअर डिवायडेड बाय epsilon 0 स्क्वेअर असणार आहे. तो epsilon 0 divided by epsilon 0 square is 1 upon epsilon 0. It will be K divided by epsilon 0 into sigma square. तो तुमचा ऑप्शन ए काय बघा, ऑप्शन ए इज हाफ सिग्मा स्क्वेअर डिवायडेड बाय epsilon 0. इथे पण के येणार कारण तुमचा इथे स्क्वेअर येणार, इथे इथे के येईल आणि इथे के स्क्वेअर येणार इथे, आणि के अपॉन के स्क्वेअर इज के येणार इथे. सो बोथ ऑप्शन ए अँड बी आर करेक्ट ऑप्शन. के का मल्टिप्लाय करायचं, कारण के म्हणजे रिलेटिव्ह परमिटिव्हिटी आहे. एअरला के इज इक्वल टू 1 असणार आहे, जर ग्लास असेल तर इट मे बी ग्रेटर दॅन 1, फॉर एनी डेन्स मीडियम द के इज ग्रेटर दॅन 1. त्यामुळे इथं के इथं मल्टिप्लाय करावं लागेल. सो बोथ ऑप्शन ए अँड बी आर करेक्ट. करेक्ट ऑप्शन तुमचा हा असणार डी, बोथ ए अँड बी आर करेक्ट. आता नेक्स्ट एक्झाम्पल सॉल्व्ह करूया. आता हा एक्झाम्पल जो आहे हा सिरीज कॅपॅसिटरवर आहे. आता तुम्ही स्टडी केला असेल, जर दोन कॅपॅसिटर सिरीज मध्ये असतील, लेट कन्सिडर C1 and C2 are connected in series, then what will be the equivalent capacitance? The equivalent capacitance is C1 into C2 divided by C1 plus C2. आता हे कसं कॅल्क्युलेट करतात, with the help of the this equation, inverse of equivalent capacitance is equal to sum of inverse of individual capacitors, 1 upon C1 plus 1 upon C2. तो हे सॉल्व केल्यानंतर तुम्हाला काय येणार मिळणार, CS is equal to C1 C2 divided by C1 plus C2. तो ह्या बेसवर हा एक्झाम्पल सॉल्व करायचा. आणि जर दोन कॅपॅसिटर पॅरलल असतील, आता इथे बघा या एक्झाम्पल मध्ये C1 and C2 हे पॅरलल मध्ये आहेत. तर इक्विव्हॅलेंट कॅपॅसिटन्स काय असणार? ऍडिशन ऑफ C1 and C2 असणार. Isn't it? मग हे दोन जर इक्वेशन जर माहित असतील तर तुम्हाला हा प्रॉब्लेम सॉल्व्ह करता येईल. आता ह्या प्रॉब्लेम मध्ये काय दिलेलं आहे? फाइंड द इफेक्टिव्ह कॅपॅसिटन्स बिटवीन ए अँड बी. ए आणि बी मधला इफेक्टिव्ह कॅपॅसिटन्स फाइंड आउट करायचा आणि कॅपॅसिटन्स व्हॅल्यू दिलेले आहेत. C1 आता हा जो आहे हा C1 आहे, हा C2 आहे, हा C3 आहे, दिस इज C4 आणि हा काय आहे C5 आहे. तर कसं कॅल्क्युलेट करायचं? आता हे फिगर जे आहे इट इज क्वाइट कन्फ्युजिंग फिगर. तुम्हाला असं कळत नाही की कुठला सिरीज मध्ये आणि कुठला पॅरलल मध्ये. यू ट्राय टू सिम्प्लिफाय द फिगर और सर्किट फर्स्ट. आता हे सिम्प्लिफाय कसं करायचं बघा. फर्स्ट नोट 4 पॉइंट ए बी आणि सी अँड डी असे 4 पॉइंट मी इथे प्लॉट केलेले आहेत आणि आपल्याला कॅपॅसिटन्स ए आणि बी मधला कॅल्क्युलेट करायचा. आता हे बघा C1 इज कनेक्टेड बिटवीन ए अँड सी. C1 कुठे कनेक्टेड आहे? ए आणि सी मध्ये कनेक्टेड आहे. C1. नेक्स्ट C2 कुठे कनेक्टेड आहे? सी अँड डी मध्ये कनेक्टेड आहे. So C2 is connected between C and D, isn't it? त्याच्यानंतर नेक्स्ट C3 is connected between D and B. D and B मध्ये C3 कनेक्टेड आहे. नंतर C4 कुठे आहे बघा? A आणि D मध्ये आहे. E आणि D कुठला आहे बघा? हे हा C4 आहे. आणि लास्ट C5 कुठे आहे? C आणि B मध्ये आहे. हा एक ब्रिज सर्किट आहे आणि C1 च्या व्हॅल्यू C1 C3 C4 C5 याच्या व्हॅल्यू दिलेल्या आहेत. सगळ्या सेम व्हॅल्यू आहेत बघा इथे. ऑल व्हॅल्यूज आर सेम अँड इट इज इक्वल टू 4 मायक्रोफॅरेड. C1 is 4 microfarad, C5 is 4 microfarad, C3 is 4 microfarad, and C4 is also 4 microfarad. And you studied the concept of bridge circuit. The bridge circuit तुम्हाला माहित आहे. When bridge circuit is a balance, when C1 divided by C4 is equal to C5 divided by C3. C5 divided by C3 is equal to C1 divided by C4 असेल, then bridge is balanced bridge. Bridge काय असतो? बॅलन्स्ड असतो. आणि जर ब्रिज बॅलन्स असेल तर इथून करंट फ्लो होणार का? फ्रॉम C to D. The current cannot flow from C to D. So this branch will be open because current is not flowing at all. कारण बघा C1 आणि C4 हा रेशो काय असणार आहे? 1 असणार आहे. इज इक्वल टू C5 डिवाइडेड बाय C3 इज इक्वल टू 1. So bridge is a balanced bridge. So the branch CD is open. C2 इथे पिक्चर मध्ये येणार नाही इथे. Isn't it? Current will not flow from C to D. आता बघा सर्किट सिंपल झालं. आता C1 आणि C5 काय ते सिरीज मध्ये आहेत. C4 and C3 are in series and these two series combination are in parallel. So find out first series combination of C1 and C5. काय येणार? CS1 काय येणार? C1 C5 divided by C1 plus C5 काय येणार? 4 into 4 divided by 4 plus 4. Every capacitor has a value of 4 microfarad. So it will be 16 divided by 8 is equal to 2 microfarad. Similarly, series combination of the capacitance in the second branch is also 2 microfarad because values are same. Now 2 microfarad and 2 microfarad are in parallel, and 2 plus 2 become 4. So new circuit is CS1 of value 2 microfarad is in parallel with CS2 of 2 microfarad between point A and B. So what will be the total capacitance? The total capacitance is sum of these two capacitance. It will be 4 microfarad. So equivalent capacitance between A and B is 4 microfarad. Now look at the correct option. The correct option is not given, but the correct option is a 4 microfarad, isn't it? So in this way you find out the total capacitance between any two terminal. हे सॉल्व केलं आपण, हे पण सॉल्व झालं. हे नंतर मी सांगतो. फर्स्ट ऑफ ऑल आय वुड लाईक टू कव्हर सिंपल प्रॉब्लेम. बघा आता हे दोन आता 70 आणि 71 आहेत, एकदम सिंपल आहेत. दिस क्वेश्चन आस्क इन द MHTCET एक्झाम. आता पहिला क्वेश्चन काय आहे बघा. द एनर्जी रिक्वायर्ड टू मूव्ह अ चार्ज of 0.25 coulomb between 2 points is 4 into 10 to the power 20 electron volt. The potential difference between two plate काढायचं आहे. आता हे एक्झाम्पल सॉल्व करण्यासाठी तुम्हाला एनर्जी स्टोर्ड और एनर्जीची तुम्हाला इक्वेशन्स माहित पाहिजे. So equation of the energy E is equal to Q हे इक्वेशन लक्षात ठेवा. Q into V, isn't it? एकदम सिंपल इक्वेशन आहे. E is equal to Q into V. त्यामुळे V काय येणार? E डिवायडेड बाय Q येणार. आता E दिलेला आहे, Q दिलेला आहे. आता आपल्याला व्होल्टेज हा व्होल्ट मध्ये कॅल्क्युलेट करायचा आहे. त्यामुळे इथं यू हॅव टू मल्टिप्लाय विथ चार्ज ऑन इलेक्ट्रॉन, where charge on electron is 1.6 into 10 to the power minus 90 coulomb. हे का मल्टिप्लाय करायचं? कारण वी वॉन्ट द व्होल्टेज इन SI युनिट व्होल्ट. आता तुम्हाला एनर्जी दिलेली आहे. एनर्जी किती आहे बघा. द एनर्जी इज 4 into 10 to the power 20. 4 into 10 to the power 20. आणि टोटल चार्ज किती आहे? 0.25 आहे. and charge on electron is 1.6 into 10 to the power minus 19. Isn't it? आता हे सॉल्व करा. So this will be 4 divided by 0.25 काय येणार आहे? It will be 16 into 10 to the power 1 in 20 minus 19 म्हणजे इथे 1 येणार into 1.6. Isn't it? 0.25 is 1 upon 4 and 4 will come at numerator, it becomes 16. So 16 into 1.6 into 10 to the power 1 and unit काय असणार? व्होल्टेज. तर 16 into 1.6 काय येईल ते कॅल्क्युलेट करायचं. तुमचा बघा 16 into 1.6 किती होतं बघा. लेट वी मल्टिप्लाय. थोड़ा 16 multiplied by 6 is 96. ठीक है. ये 16 into 1 into 9 म्हणजे 25 येणार. Isn't it? And it will be 225.6. is equal to 25.6 into 10 to the power 1. So voltage is 256 volt. So what is the correct option? The correct option is 256 volt. Isn't it? आता ह्या एक्झाम्पल मध्ये काय दिलेलं आहे? अ पॅरलल प्लेट कॅपॅसिटर हॅज अ कॅपॅसिटी सी, म्हणजे कॅपॅसिटन्स दिलेला आहे. and if medium is a dielectric constant K is introduced between plate, then capacity of the capacitor. आता तुम्हाला माहित आहे the equation of the capacitor इथे सॉल्व करतो. C is equal to epsilon 0 A divided by D. Let's consider C1. Now the medium, dielectric medium with the constant K is added. So C2 is equal to epsilon 0, now K is added here, into A divided by D. Isn't it? So C2 is equal to K into epsilon 0 A divided by D, where epsilon 0 A divided by D is nothing but C1. So what is C2 after adding the K? It will be K into C1. Isn't it? So what would be the correct option? त्याच्यामध्ये करेक्ट ऑप्शन काय असणार? K into C असणार. हा एकदम इझी असतात एक्झाम्पल, बट यू ट्राय टू अंडरस्टँड द प्रॉब्लेम and then you solve it. इथे बघा, the unit of electric flux. This example is asked in the MHTCET exam. आता तुम्हाला गॉस लॉ आठवावं लागेल इथे. What is the Gauss law? Gauss law states that the line of electric flux crossing the closed surface is equal to surface integration of E bar dot ds bar. Or in simple way, the line of flux is a product of electric field and the surface area. And you know the definition of electric field? The electric field is defined as change of potential with respect to distance. So you may write the line of flux is equal to voltage per unit distance multiplied by surface area. आता तुम्हाला माहित आहे the unit of voltage is volt. What is the unit of distance? Unit of distance is meter, and unit of area is meter square. So after simplifying, you will get the unit of flux. The unit of flux must be voltmeter. So very simple. So इथे options काय काय दिलेलं आहे बघा. The first option is a voltmeter. Second option is volt per meter. The volt per meter is incorrect because you know the flux is a product of E and S. Volt per meter is a unit of electric field, isn't it? So this is a unit of electric field. Next option काय दिलंय बघा, Newton meter per coulomb. It's also incorrect. इथं फोर्सचा काय संबंध येत नाही, इथे फ्लक्स आहे इथे. And D is also incorrect. So correct option is voltmeter, isn't it? आता हे हा प्रॉब्लेम थोडा ट्रिकी आहे, बट यू हॅव टू सॉल्व. आणि इथे गॉस लॉ इथे अप्लाय करायचा आहे. इथे काय दिलेलं आहे बघा, द कन्सिडर अ स्पेअर ऑफ रेडियस आर and cylinder of length L, and if both have same charge densities. The charge density माहिती आहे तुम्हाला, what is charge density? Charge per unit area. If both have same charge density and ES and EC are the electric intensity at a point at distance r from axis of sphere and cylinder respectively, then what is ES? आता ES तुम्हाला कॅल्क्युलेट करायचं. तर हे कसं कॅल्क्युलेट करायचं? सो लेट वी सॉल्व. यू हॅव टू अप्लाय गॉस लॉ. इथे सॉल्व करतो मी. तर पहिल्या केसमध्ये काय दिलेलं आहे, वन स्पेअर गिवन, हा स्पेअर दिलेला आहे. and the radius of sphere is capital R. The charges given on the sphere is Q, isn't it? And electric field ES at distance R given. What is ES? ES is equal to Q divided by 4 pi epsilon 0 R square. Isn't it? आता काय करायचं आहे तुम्हाला? You have to represent Q in terms of surface charge density. So how to calculate surface charge density? Surface charge density is Q divided by area of sphere. आता area काय कसा असणार आहे? 4 pi into capital R square, where R be the radius of sphere. So that implies Q is equal to sigma into 4 pi R square, isn't it? So what is ES? ES is sigma into 4 pi into R square divided by 4 pi epsilon 0 small r square. So ES काय येईल बघा इथे? ES is equal to sigma into R square divided by epsilon 0 into small r square. हे झाला ES, इक्वेशन नंबर 1. आता सेकंड केस मध्ये काय दिलेलं आहे? इन द सेकंड केस वन सिलेंडर इज गिवन. असा सिलेंडर दिलेला आहे, and cylinder is also special Gaussian surface whose radius is capital R. The charges given on the cylinder same Q. और surface charge density का same है. And what is the electric field at distance point due to cylinder EC? So EC is equal to Q divided by 2 pi into epsilon 0 into R, where R is the distance between axis of the cylinder and the observer point, that is R, into length, where L be the length of cylinder. लेंथ किती आहे त्याची? L आहे. तर हा ऍक्च्युअली काय आहे बघा? 2RL is actually spherical area. Now find the surface charge density. Surface charge density is total charge divided by surface of cylinder. How to calculate surface of cylinder? It is 2 pi into capital R into L. Isn't it? Actually capital L आहे. आता इथे सबस्टिट्यूट करा. Q is equal to sigma into 2 pi R into L. And what will be EC? EC is equal to sigma 2 pi cancel, L will be cancel, sigma into capital R divided by epsilon 0 into small r. Isn't it? आता दोघांचा सिग्मा काय सेम आहे. हा सिग्मा आणि हा सिग्मा काय सेम आहे. तर इथे बघा, इथे यू कॅन रिप्लेस sigma by, so what is sigma here? Sigma is equal to EC into epsilon 0 R divided by capital R. So substitute sigma here and determine ES in terms of EC. So इथे सॉल्व करूया आपण. इथे मी थोडा रब करतो काही पोर्शन. हा पोर्शन रब करतो. आता बघा ES काय येणार बघा इथे. ES इज इक्वल टू सिग्मा काय आहे तुमचा? सिग्मा इज इक्वल टू EC into epsilon 0 into capital R divided by इथे येणार, इथे स्मॉल r आहे, इथे कॅपिटल R येणार, epsilon 0 R square and इथे capital R. So small r and this square, it will become 1 upon R, and इथे क्या येणार? R येणार. Epsilon 0 will be cancelled, and final answer ES is equal to EC into capital R divided by स्मॉल आर, EC असेल cylinder. So what is the correct option? Look at EC. First option is correct. EC into capital R divided by small r. इथं गॉज लॉ तुम्ही अप्लाय करताय. आता गॉज लॉ ज्यावेळेला गॉज लॉ च्या बेसवर ज्यावेळेला एक्झाम्पल येतील त्यावेळेला तुम्हाला हे 3 इक्वेशन तुमच्या लक्षात पाहिजेत. पहिला इक्वेशन फ्लक्स इज इक्वल टू E into S. सेकंड इक्वेशन E is equal to Q divided by 4 pi epsilon 0 R square. जर तुमचा चार्ज हा स्पेरिकल असेल आणि जर सिलेंड्रिकल असेल तर इट विल बिकम Q upon 2 pi epsilon 0 R असणार. दिस इज फॉर सिलेंडर, दिस इज फॉर स्पेअर. आणि नंतर काय येणार, सरफेस चार्ज डेन्सिटी Q divided by S. Q divided by S, where S be the area of the object. It may be cylinder, it may be sphere, isn't it? In this way you try to solve the various example. आता हे पण तसंच आहे बघा. If the charge Q is induced on outer sphere of radius R, then intensity at point P at a distance S from the center is inversely proportional to S plus R square, inversely proportional to R square, inversely proportional to S square, and directly proportional to S square. हे हा एक्झाम्पल मध्ये काय दिलेलं आहे, सेम एक्झाम्पल आहे हा, खरं आरच्या जागी ते एस दिलेला आहे, वेर एस बी द डिस्टन्स बिटवीन ऑब्झर्वर पॉइंट अँड द सेंटर ऑफ द स्पेअर. इथं आरच्या जागी काय येणार, इथे एस येणार. इथे हे सॉल्व्ह केलेलं आहे आपण. सो व्हॉट इज इलेक्ट्रिक फील्ड, एस इज इक्वल टू सिग्मा R square divided by epsilon 0 into S square येणार इथे, where R is replaced by S. So ES is inversely proportional to S square. काय येणार, ES is inversely proportional to S square येणार. So which is the correct option? This one, C. If charge Q is induced on the outer surface of the sphere of radius R, म्हणजे तो स्पेअर आहे, त्याचा रेडियस आर आहे आणि त्या स्पेअरवर चार्ज इंड्यूस केलेले आहेत, किती, क्यू केलेले आहेत, क्यू चार्जेस आहेत. तर इलेक्ट्रिक फील्ड काय असणार आहे, इलेक्ट्रिक फील्ड इज इक्वल टू एस इंटू आर स्क्वेअर डिवायडेड बाय एप्सिलॉन 0 इंटू एस स्क्वेअर, वेअर आर बी द रेडियस ऑफ द स्पेअर and what is S? S is the distance between observer point and the location of the sphere. So correct option काय येईल बघा. आता सिग्मा तुमचा कॉन्स्टंट असणार आहे, R is a constant, epsilon 0 is constant. So electric field is inversely proportional to S square. So option C is the correct option. अशा पद्धतीने तुम्ही सॉल्व करा. आता हे बघा, हे सिरीज आणि पॅरलल कॉम्बिनेशन वर एक्झाम्पल दिलेले आहेत. When 3 identical capacitors are connected in series, the equivalent capacitance is 2 microfarad, and now they are connected in parallel across a source of voltage 200. So what will be the energy stored? So पहिल्यांदा तुम्हाला C ची व्हॅल्यू फाइंड आउट करावं लागेल. आता C ची व्हॅल्यू कसं कॅल्क्युलेट करायचं हे बघा. आता पहिल्या केसमध्ये काय दिलेलं आहे, the 3 identical capacitors are connected in series आणि त्याचा इक्विव्हॅलेंट कॅपॅसिटन्स काय आहे, सिरीज 2 मायक्रोफॅरेड आहे. तर C कॅल्क्युलेट करायचं आहे. तुम्हाला माहित आहे 1/CS इज इक्वल टू 1/C प्लस 1/C प्लस 1/C. So what is 1/CS? 1/CS is 3 divided by C. So what is C? C is equal to काय येणार, 3 into CS येणार. So individual capacitance is 3 into 2 microfarad. काय येणार, 6 microfarad येणार, isn't it? आता हेच कॅपॅसिटर्स काय केलेले आहेत, कनेक्टेड इन पॅरलल, isn't it? आता बघा इथे मी ड्रॉ करतो इथे. द सेम कॅपॅसिटर्स आर कनेक्टेड इन पॅरलल नाव. इथे असे पॅरलल कनेक्शन्स आहेत. अँड व्होल्टेज अक्रॉस पॅरलल कॉम्बिनेशन ऑफ द कॅपॅसिटर्स इज 200 व्होल्ट. त्याच्या अक्रॉस व्होल्टेज किती दिलेला आहे? 200 व्होल्ट दिलेला आहे. आता सी तुम्हाला माहित आहे 6 मायक्रोफॅरेड, 6 मायक्रोफॅरेड अँड 6 मायक्रोफॅरेड आर कनेक्टेड इन पॅरलल. आता हे तिघांचे ऍडिशन होणार पॅरलल मध्ये. ऍडिशन झाल्यावर टोटल कॅपॅसिटन्स काय येणार? 18 मायक्रोफॅरेड. आता तुम्हाला काय फाइंड आउट करायचं आहे? एनर्जी स्टोअर्ड. अँड व्हॉट इज द इक्वेशन ऑफ एनर्जी स्टोअर्ड? यू शुड रिमाइंड द इक्वेशन फॉर एनर्जी स्टोअर्ड. हाफ इंटू सी इंटू व्ही स्क्वेअर. इथं सीपी घ्यावं लागेल तुम्हाला, इक्वलंट कॅपॅसिटन्स. इट इज इक्वल टू 1/2. आता सीपी किती आहे बघा? इंटू 18 इंटू 10 टू द पॉवर -6 आणि इथे 200 चा स्क्वेअर. isn't it? तो एनर्जी स्टोअर काय येणार? एनर्जी स्टोअर 18 डिवायडेड बाय 2 इज 9 इंटू 10 टू द पॉवर -6 इंटू 200 स्क्वेअर इज 40000. किती येणार? 40,000. So this will be 36, then 4 zeros into 10 to the power -6. आता आपल्याला आन्सर कशामध्ये काय आहे बघा, ऑप्शन्स काय आहेत बघा इथे बघा. 36 इथे येत आहे आपला. 36 आन्सर आलेला हा असणार आहे 0.36. कसं येतो बघा 0.36. इथे 6 डिव्हिजन टुवर्ड्स लेफ्ट यायचं बघा. 1 2 3 4 5 आणि 6. 0. काय येणार इथे? 0.36 जूल येणार. सो करेक्ट ऑप्शन काय असणार? 0.36. isn't it? हे ना, हे वरच आहे एक्झाम्पल. करेक्ट ऑप्शन 0.36. ज्याला कॅपॅसिटर आणि एनर्जी डेन्सिटीवर एक्झाम्पल विचारतील त्यावेळेला तुम्हाला हे 3 इक्वेशन लक्षात ठेवावं लागेल. पहिला इक्वेशन काय येणार? हाफ सी व्ही स्क्वेअर, वेर ई इज एनर्जी, व्ही इज अ व्होल्टेज आणि सी इज अ कॅपॅसिटन्स. किंवा हे पण लक्षात ठेवा, हाफ एप्सिलॉन 0 इंटू के इंटू ई स्क्वेअर. हा एक लक्षात ठेवावा लागेल इक्वेशन. काय वेळेला इलेक्ट्रिक फील्ड देतात, ऍक्च्युली ही एनर्जी आहे इथे. हा थांबा, इथे एनर्जी लिहितो मी. En म्हणजे एनर्जी आणि हिअर दिस ई इज अ इलेक्ट्रिक फील्ड. या इक्वेशनवर पण तुम्ही एनर्जी फाइंड आउट करू शकता. किंवा एनर्जी इज इक्वल टू हाफ इंटू सी. आता व्ही म्हणजे काय बघा, इथे चार्ज आणि जर काय वेळेला चार्ज पण दिलेला असतो. व्हॉट इज व्ही? व्ही इज इक्वल टू क्यू डिवायडेड बाय सी. व्हॉट इज व्ही? व्ही इज क्यू डिवायडेड बाय सी. इथे काय येणार? क्यू स्क्वेअर डिवायडेड बाय सी स्क्वेअर येणार. सो एनर्जी इज इक्वल टू हाफ क्यू स्क्वेअर डिवायडेड बाय सी. असे 3 इक्वेशन तुम्हाला लक्षात पाहिजेत. तर तुम्ही एनर्जी आणि कॅपॅसिटन्सवर एक्झाम्पल तुम्ही सॉल्व्ह करू शकता. आता नेक्स्ट एक्झाम्पल. आता या एक्झाम्पल मध्ये काय दिलेलं आहे? हाऊ डू यू अरेंज 4 इक्वल कॅपॅसिटर ऑफ 4 मायक्रोफॅरेड टू गेट इफेक्टिव्ह कॅपॅसिटी ऑफ 3 मायक्रोफॅरेड. आता ऑप्शन दिलेला आहे 3 इन सिरीज, 1 इन पॅरलल, 2 इन पॅरलल, 2 इन सिरीज, 3 इन पॅरलल, 1 इन सिरीज अँड ऑल इन सिरीज. आता ज्यावेळेला ह्या टाईपचे एक्झाम्पल असतात त्याला 1 बाय 1 तुम्हाला सॉल्व्ह करावं लागेल, तरच तुम्हाला सॉल्व्ह करता येईल. isn't it? आता मी हा ऑप्शन मी ट्राय करतो, ऑप्शन सी. आता या ऑप्शन मध्ये काय केलेलं आहे, 3 पॅरलल मध्ये आणि एक सिरीज मध्ये आहे. आणि ईच कॅपॅसिटर हॅज अ व्हॅल्यू ऑफ 4 मायक्रो फॅरेड. आणि इक्वलंट कॅपॅसिटन्स किती पाहिजे आपल्याला, 3 पाहिजे. सो लेट वी ट्राय फॉर दॅट ऑप्शन. आता 3 कॅपॅसिटर पॅरलल मध्ये घ्या. 3 पॅरलल मध्ये आहेत, 4 4 4 हे मायक्रो फॅरेड मध्ये आहेत सगळे. आणि हे सिरीज मध्ये, चौथा हा सिरीज मध्ये आहे, हा पण 4च आहे. तर हे टोटल किती येईल, आता पॅरलल असल्यामुळे काय 4 + 4 + 4 इज 12 येणार. सो 12 microfarad in series with 4, isn't it? Now 12 is in series with 4, so 1 upon cs is equal to 1 upon 12 plus 1 upon 4. You solve it, it will, LCM is 12, so it will be 1 plus 3. 3 4 is 12 है ना. ते चारित्रिकम 12 येणार इथे. काय येणार, 1 upon cs is equal to 4 divided by 12 is equal to 1 upon 3. So cs is equal to 3 microfarad. So option C must be correct. असं तुम्हाला 1 by 1 तुम्ही सॉल्व्ह करून बघा, तर तुम्हाला करेक्ट ऑप्शन एखादा मिळणारच. सो ऑप्शन सी इन दिस एक्झाम्पल इज अ करेक्ट ऑप्शन, इजंट इट? आता हा एक्झाम्पल विचारलेला आहे बघा MHCT मध्ये. नेक्स्ट वन हे सॉल्व्ह केलेलं आहे आपण. आता इथे हे इलेक्ट्रिक फील्डवर आहे. इन दिस फिगर द इलेक्ट्रिक फील्ड लाईन्स इन अ सर्टन रिजन आर शोन. एका रिजन मध्ये इलेक्ट्रिक फील्ड रिप्रेझेंट केलेलं आहे. अँड यू हॅव टू फाइंड द रिलेशन फॉर इलेक्ट्रिक फील्ड ॲट ईच पॉइंट. आता तुम्हाला माहित आहे द इलेक्ट्रिक फील्ड इज रिप्रेझेंटेड बाय लाईन. Suppose there is a positive charge here, and if there is a positive charge, the line of electric field is originating from the positive charge and terminate at infinite distance, isn't it? And you know the electric field is Q divided by 4 pi epsilon 0 into R square. The electric field is inversely proportional to square of distance between observer point and the location of charge. As you go away from the charge, the line of electric field will become weak and weak. Electric field become weaker. आता इथे बघा, you can see over here at this region the spacing between these two lines is less. So electric field is a stronger nearer to charge plus Q. As you go away from the point charge, the spacing between two lines is increasing and electric field will become weaker and weaker. So magnitude of electric field is directly proportional to spacing between these two lines, isn't it? So that property you have to apply to find the relation between Ex, Ey, Ez in this case. आता इथे बघा at point Ex, आता Ex इथे एक्स काय तुम्हाला इलेक्ट्रिक फील्ड कॅल्क्युलेट करायचं मॅग्निट्यूड. आता ऍट पॉइंट एक्स द स्पेसिंग बिटवीन इलेक्ट्रिक फील्ड इज क्वाइट स्मॉलर कम्पेअर टू ऍट पॉइंट झेड. इथे जास्त आहे बघा. इलेक्ट्रिक फील्ड ऍट एक्स इज ई एक्स, इलेक्ट्रिक फील्ड ऍट वाय इज ई वाय, and electric field at Z is Ez. Now, as far as spacing between these two lines is concerned, the spacing at Z is larger. So Ez is less than Ey, and it will also less than Ex, isn't it? But what is the relation between Ex and Ey? You look at the spacing. The spacing between these two lines at point X and Y are approximately same. So we can say the magnitude of Ex and Ey are same. But at point Z, the spacing between two lines is larger compared to this spacing. So we can say Ey is less than Ez, isn't it? So which option is correct option? So option D is correct, isn't it? So that property, which property? The magnitude of electric field is directly proportional to the spacing between two line of field. That property you have to use. आता इथे बघा द पॅरल प्लेट कॅपॅसिटर दिलेला आहे of 100 picofarad, and when the plate of the capacitors are separated by distance t and metallic thickness is t by 3 is introduced, so what will be the capacitance of modified capacitor? आता पहिल्या केसमध्ये काय दिलेलं आहे बघा, the two plates are given and spacing between two plate is t. T is the spacing between two plate. Let's consider area of the plate is A. So C is equal to काय येणार epsilon 0 A divided by T येणार आणि याची व्हॅल्यू किती आहे 100 मायक्रोफॅरेड आहे. आता नंतर काय केलेलं आहे, then the metallic foil of thickness T by 3 is introduced. म्हणजे काय केलेलं आहे, the thickness of this two plate is increased and total thickness added किती असणार आहे T by 3 असणार आहे. So what will be the modified capacitance? The modified capacitance is epsilon 0 A. Now the modified thickness is T minus T by 3, isn't it? So you solve it. So it will be epsilon 0 A divided by 3T minus T divided by 3. So C1 is equal to 3 epsilon 0 A divided by 2 into T, where epsilon 0 A divided by T is known and it is equal to 100 microfarad. So correct answer is 3 by 2 into 100 microfarad, isn't it? So what is the correct option? 3 by 2 into 100 मायक्रो नाही तर पिको दिलेला आहे. युनिट काय डझंट मॅटर कारण आपण तिथे काय चेंज केलेच नाही. इथे पिको घ्या, इथे डोंट टेक मायक्रो, कन्सिडर पिको फॅरेड. द करेक्ट ऑप्शन इज 3 by 2 into 100 picofarad, ऑप्शन बी. अशा पद्धतीने सॉल्व करायचं. तुमची इक्वेशन तुम्हाला लक्षात पाहिजे तर तुम्हाला सॉल्व करता येईल. तर आज आपण इथे संपूया. तर टुमॉरो आय विल टेक अ lecture on electrical circuit, the chapter number 9 of your syllabus, and that chapter is dealing with the electrical circuit, Kirchhoff's current law, Kirchhoff's voltage law, then the drift velocity, all those things. will potentiometer, bridge circuit हे सगळं आहे त्याच्यात. हे आपण उद्या घेऊया आणि उद्या येताना नोटबुक घेऊन या जेणेकरून आपण जे इथे सॉल्व करतो एक्झाम्पल यू ट्राय टू अंडरस्टँड अँड ट्राय टू सॉल्व युअर सेल्फ ऑल्सो. So we'll stop here and thank you for joining the lecture.